Hi everyone, welcome to the lecture on gradient. So before we go and see what is gradient, what is the use of gradient operator, we must understand the one operator which is playing very crucial role in finding the gradient. So first we will see that operator is known as del operator. So what is del operator? Del operator, we are denoting del operator by this symbol del. This symbol is known as del. So it is a vector differential operator. We can define del operator by del is equal to I into dou by dou x, j into dou by dou y plus k into dou by dou z. Why it is called vector differential operator? Hope you have known now. Because I, j and k, these are all vectors, unit vectors, and dou by dou x, dou by dou y and dou by dou z are differential operators. So del operator is a vector differential operator. What this del will do is it will act on either vector or scalar field and will create a new field. That new field may be either a scalar field or vector field. So let us see how del operate on different field. So here you see, here del operates on a scalar, V is a scalar. Here del operates on a scalar and will produce a vector. If del operates on a scalar and produces vector, means that operation is known as gradient. Here second one you see, here del operates on V vector. So if del operates on a vector and if it that results in a scalar, then that operation is known as divergence. Why it results in scalar? Because del is a vector operator, we know. If you take a dot product of two vectors, the result will be a scalar. So del operates on a vector. If it produces a scalar, then that operation is known as divergence operator. Then third one you can see here, del operates on a vector which will result in a vector because we are taking a cross product. We know that cross product of two vectors is another vector. So here del operates on vector V and produces another vector. If del operates on one vector and which results in another vector, then that operation is known as curl. Fourth one we can see, here del operates on scalar which is resulting in another scalar. You see V is a scalar. So here del operates on a scalar and it will result in another scalar. This operation is known as Laplacian operation. So we can expect one question from a competitive exam from this area. Now we will go to gradient. What is gradient? We must know what is gradient first. Gradient is an operator which will give maximum change of any scalar field. Maximum change. If you want to find where is the maximum change of any scalar field, we have to use gradient operator. Simply to find the maximum rate of change of any scalar, then we can see, or we can use a gradient operator. So we know that vector differential operator del, which is given by I into dou by dou x plus j into dou by dou y for 2 dimension, and del is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z for 3 dimension. Okay, right. Here we are going to study about gradient. So gradient means del operator operates on a scalar. Let us take one scalar function f of xy. It is a 2 dimension, so I have to use 2 dimensional differential operator. So del f of xy gives dou f. So I have to take del of this I into dou by dou x f plus j into dou f by dou y. So this is a 2 dimensional scalar operator. Suppose if I go for 3D operation, then del of fxyz is equal to dou f by dou xi, dou f by dou yj plus dou f by dou z k. So all these three results in vector because the result is having unit vector I, j, k. So gradient will result in a vector quantity. So gradient is a vector quantity. So how do we get gradient? If you operate your del on a scalar function, it will result in a gradient. So what is the significance of gradient? We know that a gradient is a vector. So let us take one scalar function. Del operates on a scalar function and it will result in a vector. So del t is a vector because del operates on a scalar and the result is a vector. So let us take t is t is a temperature. So del t is a temperature gradient. If you consider t as temperature, we know that temperature is a scalar. So del operates on a scalar which will result in a gradient. So temperature is a scalar. Temperature gradient is a vector. So del T is a temperature gradient. So it is a vector quantity. We know that a vector has both magnitude and direction. Let us see what is the meaning of magnitude of gradient and what is the meaning of direction of gradient. So here we can see that direction of gradient del T, that is temperature gradient, indicates in which direction we will feel the maximum rate of change of the temperature. So let us take our home. When we enter into our home, we know that if we go from hall to kitchen, we will see maximum increase in gradient or temperature gradient because compared to hall, the kitchen is having more temperature. So this is positive temperature gradient. Suppose if we move from our hall to bedroom which is having AC, then we feel that temperature is less in the bedroom compared to the hall. That means we are moving in the direction towards least temperature in the home. So it is a negative temperature gradient. So if you find the gradient, it will indicate where is the maximum change. So gradient is a vector quantity. The direction of gradient indicates in which direction we will feel the maximum change, and the magnitude indicates what is the value of that maximum. So what we understand from this gradient operator is, we know that gradient is a vector. It has both magnitude and direction. So the magnitude of gradient indicates what is the maximum rate of change of parameter. Here the temperature. Similarly, the direction of gradient indicates in which direction that maximum rate of change occurs. Okay, here the parameter is temperature. So let us go and find gradient mathematically. So here you are given one scalar function. Because why it is a scalar? It is not having any unit vector. So it is a scalar function. So whenever you are supposed to find a gradient, they will give only scalar function because del operates on scalar which will result in a vector. So I have to, it is a f of xy is equal to 5y minus x cube y square. I have to find del f. So del f xy, it is a two dimension. So because it is having only x and y. So I go for two-dimensional gradient operator, dou by dou x fi, dou by dou y fg. So here I have to differentiate with respect to x. So first I differentiate 5y, dou by dou x 5y will give 0 because we are differentiating with respect to x. So this one becomes 0, and x cube, if you differentiate, it will become minus 3x squared into y squared I. Similarly, here I am differentiating with respect to y. So dou by dou y 5y is 5 and minus dou by x cube is constant. If you differentiate y squared, you will get 2y. So minus 2x cube yj. So here you see, here original given function is scalar and gradient is a vector. Why it is a vector? Because it has both I and j. Unit vector. Unit vector gives direction. These are all the magnitude. This is a gradient. So if in exam, if they want to find a gradient at particular point, they will give the values for x, y, and z. Suppose they may ask you to find find gradient of f of xy is equal to 5y minus x cube into y squared at 1, 2, 3. That means here x is equal, we have to find gradient at x is equal to 1, y is equal to 2 and z is equal to 3. So substitute here x is equal to 1, y is equal to 2 and z, if z is given, you substitute z is equal to 3, otherwise leave it. So that is giving gradient at particular point. So this del is a vector differential operator, we know. It is giving the value of gradient at particular point because it is having what is the rate of change at x-axis, what is the rate of change at y-axis, and what is the rate of change at z-axis. So we can find what is the rate of change at every particular point in the space. So that is a beautiful application of del. So let us see one more problem. Here you can see that here they gave, as usual, f, it is a 3-dimension. So because it is having x, y and z. So f of xy is given xy squared plus 3x squared minus z cube, and they ask you to find gradient at 2 comma minus 1 comma 4. So as usual I find gradient. First to differentiate with respect to x. So dou by dou xi. So first operator I differentiate. So x is 1. If you differentiate xy squared, y squared is a constant because it is a partial differentiation. So y squared is constant, x is 1. So y squared, here if I differentiate with respect to x, so x squared if I differentiate, it will get to 2x. So 3 into 2 is 6x. Here I cannot differentiate because it is a constant for x. So y squared plus 6xi. Then if I differentiate the same thing in with respect to y, so x is a constant. If I differentiate x squared, so 2xy, and second part if I differentiate with respect to y, I get 0 because it is a constant with respect to y. Similarly, if I differentiate z cube with respect to y, again I will get 0. So what I get is 2xyj. Next I differentiate the same thing with z. So if I differentiate first one xy squared with respect to z, what I get is 0. And if I differentiate the second part with respect to z, again it is 0 because there is no z. Then if I differentiate third part with z, it will give minus 3 z square. So minus 3 z square, it is the point. So gradient of f of xy is equal to y square plus 6xi plus 2xyj minus 3 z square k. But they didn't ask a gradient. They asked gradient at particular point 2 comma minus 1 comma 4. That means I have to substitute x is equal to 2, y is equal to minus 1 and z is equal to 4 in the above equation. So I substitute here y is equal to minus 1. So minus 1 squared is plus 1 plus 6 into x. X is 2. So 6 into 2, 8, and 6 into 2, 12, and 1 squared 1, so 13 plus 2xy. 2 into x is 2 and y is minus 1. So 2 into 2 into minus 1, it is minus 4. Minus 3 into z squared, z is 4, square is 16, 16 into 3, 48. So this is your answer.